This is the Schwerer Gustav, scuttled in 45. She sits at 420 feet. Raising 1,350 tons requires flawless...
Winch assembly looks good from here. Stand by for tension test. All stations, check your rigging. We are powering up the main hydraulics.
Confirming sonar calibration is complete on the survey unit.
Heavy-duty systems are green. Manipulators responding normally.
Weather window looks good for the next 96 hours, maintaining course 090.
There it is, gentlemen. Unmistakable metallic signature.
Schwerer Gustav located. Requesting authorization for ROV deployment.
Copy. Deployment sequence initiated. Passing 200 meters.
Systems nominal.
Depth rapidly approaching 300 feet.
Schwerer Gustav was the pinnacle of artillery excess. 1,350 tons of steel, capable of firing shells weighing as much as cars.
The barrel is sound, but we have a clean separation at the breech housing.
Confirmed. Marking optimal lift points now on the chassis and mid-barrel section.
Start with the chassis. We'll use the ROV suction here.
Copy that. Watch the current patterns. We can't afford a sediment cloud. We need to review safety protocols again.
All right, jets are active, holding steady against the back pressure. Copy that. We're clearing the muzzle section now. Rifling grooves are visible.
Assessment confirms the massive steel frame is corroded but structurally sound in critical areas.
We've identified the lifting points.
Water jets at low pressure, clearing the sediment from the loading tray hydraulics. Confirmed. The interrupted threads are visible now.
We're not just guessing whether this steel can handle the lift. We're measuring it atom by atom. 80 years of corrosion versus 1940s German metallurgy.
Inspection camera shows full penetration on weld seam Bravo.
Roger. Engineering approves the weld for load-bearing certification. Proceed to next lift point.
Sling connection secure at Gustav 4. Confirm visual green. Roger that.
Engaging hydraulics for tension test.
Tension reading nominal. Connection verified. Final bolt secured on the forward spreader bar. Calculations confirm optimal load distribution.
Roger that. Tensioning sequence initiated. Lift cables stabilizing.
Ascent stable. Load distribution nominal across all 4 cables.
Copy that. Increasing speed to time-lapse velocity.
Cable 1 adjusting. Stand by for stabilization.
We are stable at 220 tons per line, total 1320.
Tension verified. Proceed with the main lift.
Winches engaged, ascent initiated, load distribution remains stable across all 6 cables.
Confirmed. ROV tracking the barrel emergence from the seabed.
Structural integrity nominal at 210 feet. Plates holding steady.
Baseline comparison.
There she is. We got her.
All teams, stabilization lines deployed now. Let's secure this cradle.
400 tons of rifle-hulled steel that once hurled shells weighing 7 tons is now sitting on an American deck.
Tension is increasing, approaching 580 tons.
Structure holding. DP systems show minor drift.
Maintain current ascent rate. Tension increasing rapidly, approaching 75 tons.
Suction braking now. Expecting heavy displacement.
Tension stabilized, holding steady, beginning ascent. Bogey failure confirmed. Tension spike on line 3 at 12%.
Visual confirms chassis integrity, no structural damage.
Adjust winches to compensate. Continue the ascent.
All right, bring her down easy. Watch the stern cradle. Steady now. Weight bearing confirmed. Release the tension.
Winch synchronization confirmed.
Tension holding steady on all 4 cables.
Roger that. Commence ascent.
3 major components, 1,450 tons total, raised from...
Bogey assembly number 3 is on the cradle, documenting heavy corrosion now.
Copy that, deck foreman. Confirming receipt of data.
Bridge, this is the deck crew. Forward Gustav mounts checked and secure. Copy that. OSE 31 actual, ETA revised to 0600. Down slow. Watch that alignment. Got it. Millimeter to the left. Steady.
Hold the traffic at the intersection.
Ease it back 5 feet. Watch the overhang.
It barely fits through the door.
Under 80 years of Baltic marine life, the German engineering emerges.
Bore diameter measurements are holding surprisingly consistent, within 2 millimeters total variance.
Confirmed. Data transmission successful.
We must disengage the safety interlocks before we extract the block with the crane. And document the measurements on the object.
The stress analysis confirms we need replacement here at the bogey mount.
Right. Sequence welding first, then mechanical restoration, finally the surface treatment.
The surface finish is revealing nicely. We'll need to fill this pit here.
Agreed. The process was a complete success.
Every weld has to be perfect, not museum quality perfect, but combat load perfect. This chassis has to support one.
We're maintaining the rifling depth while removing the damaged layer.
Confirmed. Initial measurements show we're within tolerance for the twist rate.
Initiating elevation sequence. Movement stable to 65 degrees.
Hydraulics check good. Traverse rotation is nominal.
Loading a shell that weighs more than 2 cars requires machinery, precision, and respect.
Ballistic computer online. Running calibration sequence.
Interlocks engaged. System stabilization at 98%.
Check the tolerance on the forward mounts. We're showing a slight yaw discrepancy.
Recalibrating laser grid. Adjusting now. Alignment verified.
Approaching contact. Bearing clear on my side.
Confirmed. Lowering final 6 inches.
Trunnion seated. Engaging locking pins.
The hydraulic rotating fixtures turn the breech, engaging the massive threads. After 3 revolutions,
When Gustav fires, the recoil force exceeds 2 million pounds, enough to derail the weapon if not properly controlled.
Closing main breaker. Stand by for activation.
Panel indicators green. Motor contactors engaged. Gustav is live. Traverse initialized.
Emergency stop engaged.
Confirmed. Gustav systems check complete.
firing solution calculated. Transmitting commands now.
Weapon responding as expected. Safety interlock confirmed operational. Test complete.
1,350 tons of restored war machine rolling on tracks. It moves, it traverses, every...
Final inspection complete. All parameters green.
Gustav is certified operational. Ready for demonstration.
All right, driver, bring her left. Easy now.
Crane 1 is hot and ready for the main barrel.
Stand by for lift coordinates.
System activation sequence engaged.
All right, team, remembering CM into these S-tons.
Operating Gustav requires coordination like an orchestra. 12 people moving a 7-ton shell.
Raise the load! Watch your spacing! Moving forward! Clear left side! Breach clear! Send it home! Locked!
Hydraulics check nominal. Recoil system fully charged. Breach mechanism cycled. Verified green.
7 tons of projectile, 2 tons of propellant, sealed in a chamber that will generate pressures exceeding 50,000 psi.
Schwerer Gustav is ready to fire.
Firing! Firing signatures look good. No case ruptures. Chassis and bogies intact. Confirmed. Weapon fired successfully with no damage.
2 shots, 2 impacts, 0 failures. We've proven this restored weapon can do what the original did. Deliver massive firepower at extreme ranges.
Maximum range confirmed, 47 kilometers downrange. Impact successful. Performance validated.
Traverse complete. Stabilizing. Fire control calculating new solution. Bearing locked. Loading complete. Firing 4th round.
Load the 6th round. Shell seated. Breach closed. Firing.
We've given Gustav 21st century targeting.
The inspection validates the barrel restoration quality. Engineers estimate the restored barrel is capable of at least 300 additional firings.
Hold position. We are green for offload and assembly.
Copy that. Moving to secure the transport cradle.
Systems reactivation initiated. Pressure coming up.
And there it is. This demonstration ensures the Gustav remains active. We will now commence the firing sequence. Clear the range. Fire mission. The engineering solutions sink this level of recoil day to day. Specific
Ammunition technical descriptions highlight varied firing characteristics. Different impact signatures demonstrate tactical applications.
As the barrel elevates, note the smoothness of the hydraulic traverse mechanism.
And here we cycle the breech, demonstrating how the 7-ton round is chambered.
The engineering challenges were immense. But through international cooperation and countless hours of dedication,
Operating Gustav isn't something you learn in an afternoon. It takes weeks of training, hours of practice, and
regular maintenance keeps the Gustav operational. Technicians inspect mechanical, hydraulic, and electrical systems weekly, ensuring peak performance. For conclusions, this demonstration reveals that the Gustav is a system-level capability requiring extensive infrastructure, including ammunition transit.
While Gustav represents impressive engineering, it also highlights military excess. It was simply too logistics-intensive.
Gustav represents artillery taken to the absolute extreme. No weapon before or since has thrown heavier shells farther.
Traversing to position Bravo. Set stabilizers.
Target acquired. Fire!
Moving to Charlie.
Keep it moving. Load faster. Ready to fire. 11 rounds down. Outstanding work, team. The bore inspection confirms excellent condition. Rifling depth is well within tolerance. That validates the restoration. Another 100 rounds easy.
That smoke trail shows what's normally invisible. The shell.
Zulu Battery reports continuous operation maintained for 24 hours.
Good work, team. Shift change complete.
Fire mission complete. Stand by for the next sequence. Clear the breach. Breach clear. Roger. Fire in the hole.
This is the hydraulic power distribution system, critical for the recoil management.
We're running the finite element analysis now to check the structural load paths.
Ensure the stabilizing spades are secure before we cycle the breach.
This specific model saw service near Sevastopol.
Gustav's restoration established new standards for military equipment preservation, proving that restored can mean functioning.
The winner of the Gustav Trophy, Crew Alpha.
We are the best! Firing sequence complete. Data acquisition is nominal. Inspection confirms structural integrity.
Gustav is fully...
Yes, we did it! 51.8 kilometers!
New record!
Every crew member eventually retires, but Gustav doesn't. This next generation is learning from the generation who restored the weapon.
Automated loading sequence initiated. Monitoring shell alignment. Fire control shows a confirmed solution. The crawler reports the burst.
Our assessments confirm that while dramatic, the firing operations produce no lasting environmental harm. Noise and
the fidelity on the loading sequence is impressive. Agreed. It definitely improves our initial readiness before live fire.
As you can see, the engineering approaches differed significantly, yet each piece represents a monumental achievement.
We didn't restore Gustav to fire a few rounds and become a museum piece. This weapon will operate for as long as we may.
These inert cutaways reveal the immense engineering required for the 7-ton Gustav shells. Modern
These demonstrations validate the system's engineering quality, proving functionality in extreme summer heat, winter cold, and monsoon conditions.
Target locked. Fire when ready.
Shot confirmed. Impact within 1 meter of designated aim point.
Excellent work, team.
Solution optimized. Target acquired. Firing sequence initiated.
When we recreate historical operations, we're showing how 500 German soldiers operated this weapon under combat conditions.
The rapid expansion of gases demonstrates the incredible engineering involved. As the projectile accelerates,
The stabilized bipropellant should reduce both flash and residue.
Post-test analysis confirms consistent velocity and reduced barrel wear.
Laden! Breach secure! Ready to fire! Firing sequence complete! Textbook execution, folks! This commitment ensures that this magnificent weapon, now a national military heritage asset, will fire perpetually.
Gustav isn't just history, it's a functioning laboratory. Modern artillery can't replicate these firing conditions.
Shell away! Tracking nominal. Impact confirmed, 56.2 kilometers. We did it, gentlemen! A new world record! Round fired! Reloading! Shift change initiated, status green. Sustaining tempo, fire mission incoming.
Projecting operations through the entire 21st century requires integrating these advanced materials now.
Absolutely. Observing the Gustav operations gives you direct insight into artillery engineering. These skills are directly transferable to advanced technical careers.
Autoloader sequence is nominal. We're ready for the fire mission. Copy that. Final authorization confirmed. Digital targeting confirmed. Firing in 3, 2, 1. Rounds away. Coordinating airstrike now. Viper 2-1 engaging designated target. Good impact detected.
With Gustav as the centerpiece, this heritage tourism development attracts visitors worldwide, generating variables.
This is where the primary stress fractures occurred during recovery. Note the crystalline structure changes. Right. We need to update the phased array inspection sequence. Look at the thermal readings on Auxiliary Unit 3. It's exceeding expectations.
Recording the data now. This confirms the viability in extreme heat.
Section 1, load. Geladen. Traverse left. Adjust elevation. Ready to fire. Every time Gustav fires, we're testing materials and technologies under conditions you can't replicate in laboratories. Extreme vibration, massive shock loads.
This exhibition traces artillery evolution, showing the progression from manual smoothbore systems
Gustav provides unconventional emergency response, triggering controlled avalanches, creating fire breaks, and demolishing unstable structures rapidly.
Cables connected. We are reading biometric data now.
Confirmed. Performance metrics are streaming. Levels look stable for now.
Gustav systems are operational.
As you can see from the firing demonstration, the logistical challenges of deploying the Gustav were immense.
Gustav throws 7-ton shells 30 miles. Modern artillery throws 100-pound precision rounds the same distance. Which is better? Depends on the mission. The Perpetual Crew program ensures that institutional knowledge and operational proficiency continue uninterrupted through centuries of operations.
Trajectory and muzzle velocity are within optimal parameters.
The electromagnetic coils performed as expected. This confirms the proof of concept.
By the power vested in these organizations, we designate Gustav as protected international cultural heritage.
And that's how Schwerer Gustavs record with precision and returns.
By integrating emerging technologies, from AI optimization to quantum sensing, we ensure Gustav operations.
Thanks to the dedication of this team, we formally declare Gustav operational. This marks the beginning of perpetual operations.